Go.
Mr. Reynolds, second block, physics class, chapter 1, activity challenge. Let's go.
Ready?
Stay out there.
Today, we will explain how everyday sports is used. Newton's first law is where an object at rest will stay at rest until an unbalanced force is acted upon it. For example, the summer is in motion, and she will stay in rest until an unbalanced force is acted upon her. Stop.
As you can see, I was in rest on the running position until Mercedes came up behind me and pushed me, and I was in motion until an unbalanced force, which would be the track, pushed me, and I stopped.
Go.
Next, we're going to talk about kinetic energy. Kinetic energy is associated with motion. For example, when Chrissy and I run, we will have kinetic energy. Now, when we ran from that distance, we had kinetic energy because we were in motion. Man, it's so boring today. Hey, Christy.
Hey, Summer.
Do you know what gravitational potential energy is?
No.
Well, it's also called GPE. But gravitational potential energy is like when you're flying through the air or something like that, you have GPE because like gravity's like pulling down on you.
Really?
Yeah. It's really actually cool if you think about it.
You want
Like
to show an
sitting-
example?
Yeah, like, in a second. But like when you sit here on the high jump, think about it. High jumpers had to have a lot of GPE and
Yeah.
pole vaulters because they're going flying through the air. I'll show an example. Ooh. I'll have gravitational potential energy when I'm jumping from here to over there. Ready? I had a little bit of GPE, but I didn't come far off the ground. Well, when you get to your high point, which is from when I have like a split second of not doing anything in the air, that would be my high point, which I have the most gravitational potential energy. So how are y'all doing in physics?
I'm doing pretty good.
Good. I saw in your test you're having some trouble with elastic potential energy.
Yeah, it's kind of hard to figure out.
What don't you understand? I mean, it's not.
Well, whenever you start off, you have elastic potential energy, but once you start moving, you have none. Why is that?
Well, because elastic potential energy is like energy associated with bend and like compression or something. So when you're flying through the air, you're not bending. I mean, you might be bending, but you have like, it's GPE mostly, like gravitational. But like when you're bent like this, you have a lot of elastic potential energy, but when you jump up, you have none.
Okay.
So it's associated with bend and compression. Do you understand it?
Yeah, maybe it'll help me with on my test time.
Good.
Today we'll be talking about work. Summer, take it away.
What's up, guys? Well, today, since it's work, I gotta explain what work means to you. It's not really that hard if you think about it. Now, work in physics is a little different from work in everyday life. Work in everyday life is like a job. You're a nurse or whatever, you do your work. But in physics, you have to calculate work with a formula. Work equals F times D, which is force and distance. You have to, if you're going to have to do work in physics, you have to have a force, and it has to go a distance. Well, in track, you do a lot of work. In any everyday sport, you do a lot of work. For me to have done work, someone would have to apply a force for me, and I would have to go a distance. And Mercedes is going to be my example. Now, as she is pushing me, I'm moving a distance, and I haven't applied force upon me. Now, if she were to apply a bigger force, I have gone a farther distance, so therefore work has been calculated. So, as you can see, work is not hard in physics. Mercedes, do you remember how earlier in this video we talked about Newton's first law?
Yeah, kind of.
He has 3 laws, but we're going to go ahead and talk about the second one. Newton's second law, like, it associates with acceleration, force, and mass and acceleration. But force and acceleration are direct, and mass and acceleration are indirect. Do you get what I'm saying?
No.
No? Okay. Well, anyway, let's take a walk around this way. Anyway, force and acceleration are direct because the more force you apply to an object, the more acceleration it's going to get. So if I were to apply a good big force to you, you're going to accelerate more. But if I were to apply a smaller force to you, you're not going to accelerate. Why is that? Well, because the amount of mass an object has in it, which takes us to mass and acceleration. The amount of mass an object has in it depends on the acceleration you'll be able to give to that object. Let's say I had a humongous there. Okay? If I try to move that brick wall, it's not going to go anywhere, and it might go just a little bit, but not with much acceleration because it has a large amount of mass. Now, if I were to take you again, which has a humongous smaller amount of mass than what a brick wall is going to have, you are going to accelerate because you have less mass. Do you get it now?
Yeah.
So force and acceleration are
Indirect.
no, silly, they're direct.
Oh yeah.
Force and acceleration are
direct.
and mass and acceleration.
Indirect.
Very good. Now you understand Newton's second law.
Yeah.
Okay. This awesome physics video was produced by Summer O'Neill,
Christy Millsap. Mercedes Jones.
Victoria Laurie. Thank you. We love you.